Alright, today we're going to be talking about how to compute the cross product of two vectors. So say we have a vector v that's represented by 1, 2, 3. And we have some other vector w that's represented by 3, 4, 5. How do we compute the cross product of these two vectors? The first prerequisite that we need to know is that vectors are represented as multiples of the basis vectors. So that's I, j, and k. So we're going to use a little notational trick to help us when we're doing our cross product so that this is going to return us a vector. So when we do v crossed with w, we should get some new vector that's perpendicular, so 90 degrees, to both of these vectors. And so the way that we compute this is the easiest way to do it is just write out I, j, k, and then write out v first, 1, 2, 3, and then write out w, 3, 4, 5. And to find the I component of our next vector, the result of our cross product, all we do is we cross out the column that I is in, and we cross out the row that I is in. And we now look at what's left. And what we're going to do is we're going to take this one and multiply it with the diagonal, and then we're going to subtract the other diagonal multiplied together. So we can think of this, we're almost making sort of a fish shape like this. So I is going to be 2 times 5 minus 3 times 4, which is going to give us 10 minus 12, or negative 2. So the I component of our final vector is negative 2. Doing j is very similar. We cross out the row that j is in, cross out the column that j is in. The only thing that's different, and this is very important to remember, is that j has a negative sign at the front. But other than that, everything else is the exact same. So we've crossed out the column and row that j is in, and we look at what's left. So j is going to be 1 times 5, 1 times 5 minus 3 times 3, which is all multiplied by negative 1. So this is going to equal negative 5 minus 9, or negative 4, which can give us our final answer of 4. So the j component of our final answer is 4. And now finally, k is the exact same as I. We cross out the column that k is in, we cross out the row that k is in, and we look at what's left. We get k is equal to 1 times 4 minus 2 times 3, which is going to give us 4 minus 6, or negative 2. So our final vector, v cross w, is equal to negative 2, 4, negative 2. And we can quickly double check that when we do the dot product of this new vector with any of these, it's going to give us 0 because they're 90 degrees apart. So if we do 1, 2, 3, dot product with negative 2, 4, negative 2, we're going to get negative 2 plus 8 minus 6, which is 0. And same thing, if we were to do 3, 4, 5, dotted with negative 2, 4, negative 2, we're going to get negative 6 plus 16 minus 10, which again gives us 0. So we know that we've done our cross product right. So that's a quick trick for calculating the cross product of two three-dimensional vectors.